I am S B Mishra, going to explain you the remaining part of the chapter 3 function. In the previous lecture, I told you how to draw the graph of different function. Here one more graph for the different function. Let f is a function from real number to real number and fx is equal to greatest integer function x. I have already told you the meaning of this greatest integer function. Now the table for this x, y. If x is equal to 0, it will be 0, y will be 0. Fx is equal to y. We know that this implies y is equal to greatest integer function x. So if x is equal to 0.5, greatest integer of 0.5 is 0, 0.9, greatest integer of 0.9 is 0, greatest integer of 1 is 1, greatest integer 1.5 is 1, greatest integer 1.9 is 1, greatest integer 2 is 2, and so on. We have prepared a table. After that the graph is being drawn here. Just see the pattern of the graph starting from 0, 0, and then as soon as it will reaches 1, immediately 1 at x 1, y will be 1, so there will be a jump and here is a gap. Likewise from 1 to this will go from 1 to 2. As soon as it will reach 2, at 2 there is a jump. At x is equal to 2, y is also 2. Again this will start from 2, and in the same way we can move in negative direction. So this is the graph of greatest integer function. What is the greatest integer function? Draw its graph. So just review once more you can see here. Just remember the image of the greatest integer function in your brain, that this type of graph will appear when it will be drawn. Starting from 0, 1, there is a gap at 1, because at 1 y is 1, so this gap will be filled by this one. Again at 2 there is one more jump, and in this way from in negative direction we can also maintain the graph of greatest integer function. Smallest integer function. Smallest integer function from R to R. This is symbolized by this, read as a smallest integer function. The meaning is either x itself, or if x is integer, or integer just write to x. The examples are here. Since 2 is integer, so the answer is exactly 2, but 2.1 is not integer, so move right to this 2.5. right number is 3. Likewise 3, the smallest integer is 3. The smallest integer of 3.1, the right of 3.1 is 4. Similarly 4 is 4, but right of 4.5 is 5. So this is the smallest integer function. Once more examples are here. The smallest integer of -3 is exactly -3, but -3.1, moving right side, just right to x. So right to 3.1 is -3.1 is -3, right to -7.1 is -7, right to 10.5 is -10, and this way we can find the value of the smallest integer function. Now the fractional part is symbolized by this curly bracket x. F is a function from R to R such that fx is equal to fractional part of x, where fractional part of x denotes the fractional part. Now fractional part of 3 is 0, 7 is 0, 4.5 is 0.5. Now 3.1 is 0.1 itself, 7.1 is 0.1 itself, 3.45 is 45 itself. But in case of negative, be careful, the fractional part is undoubtedly 0 here, but in case of negative, minus 3.1 is equal to 0.9. How? Just see how how it is 0.9. Now your doubt is clear here. In case of negative decimal minus 3.5, the fractional part is written by subtracting this 0.1 from 1. This is 0.9. So 0.1. So subtract 0.1 from 1, it will become 0.9. Likewise, to find the fractional part of 0.55, 0.55 negative, subtract from 1 this 0.55, 0.45 will come. Just see first here. Fractional part of 3.45, subtract from 1 minus 0.45, this is 0.55. Minus 7.4, subtract from 1.4, 1 minus 0.4 is 0.6. Likewise, here is minus 7.1, this decimal 1 is subtracted from 1, the result is 0.9. Likewise, this minus 2.75, subtract 1 minus, subtract from 1 minus 0.75 is 0.25. Likewise 55, 1 minus 0.55 is 0.45, 0.5, 1 minus 0.5 is 0.5. Now the value of x is equal to greatest integer x plus smallest integer x, sorry, fractional part. Greatest integer x plus fractional part is equal to x. X is equal to greatest integer x plus fractional part x. The verification is done here. If x is equal to 2.4, the greatest integer of 2.4, just take 2.4 left to 2. This is 2. Earlier I have already discussed. The fractional part is 0.4. Now checking of this, x is equal to greatest integer x plus fractional part. This now RHS, greatest integer x plus fractional part x, greatest integer is 2. Here I already we have, and fractional part is 0.4. When added we get 2.4. Now LHS is exactly x is 2.4, so LHS is equal to RHS. Taking one more example, verify this. If x is equal to minus 2.4, in case of negative minus 2.4, just integer left to minus 2.4 is minus 3. So greatest integer of minus 2.4 is minus 3. Now minus 2.4, now the smallest integer, this, sorry, fractional part, this is 1 minus 0.4, this is 0.6. Now checking, x is equal to greatest integer x plus fractional part x, RHS, greatest integer x plus fractional part x, greatest integer is minus 3, fractional part is 0.6, so this is minus 2.4, and RHS is exactly x, which is minus 2.4, so LHS is equal to RHS. Now exponential function, 10th exponential function, this is a function from real number to real number such that fx is equal to a to the power x. Remember that the a is greater than 0, but a is not equal to 1. Note, in case of f is a function from R to R, fx is equal to e to the power x. This is also called exponential function, where e lies between 2 and 3. What is e? So approximately e is 2.7 approximately. Just see how it is possible. Now just know about the factorial. This is symbolized by this or this. Factorial 5 or factorial 5, both are read as factorial 5. Factorial means continued multiplication at a difference of 1 and ends to 1. This is the local definition. Now very easy. Factorial 5, 5, 4, 3, 2, 1. The last will be 1. Then multiplied we get 120. Factorial 5, 4, 3, 2, 1. Starting from 4 at a difference of 1, move towards 1. 25. Factorial 3, 3, 2, 1, 6. Factorial 2 is 2 into 1, 2. Factorial 1 is 1. But factorial 0 is also 1. You will learn later on. So wait. Factorial 0 is equal to 1. The proof will be given later on. Now, what is e? Once more your question is what is e? factorial negative is not possible. Now what is e? So just go through this activity. Take x x. Many x's are written with positive sign, and the power is written 0, then 1, then 2, 3, 4, 5. As soon as you give the power 0, immediately write factorial 0. Power 1 factorial 1, power 2 factorial 2, power 3 factorial 3. This is activity. In this activity, I have written x, many x's. Then as many power on x, as many factorial in the denominator. x0 factorial 0, x1 factorial 1. This activity will leads towards this. X to the power 0 is 1, factorial 0, 1 already told, but the proof of factorial 0, 1 will be discussed later on. X to the power 1 is x itself, factorial 1, and so on. These are as usual. Now the above activity is called e to the power x. This is nothing but e to the power x. The proof of e to the power x is equal to this will be discussed in higher mathematics, not now. But with the help of this activity, we have known that what is e to the power x. Now if e to the power x is equal to this, just put x is equal to 1 both sides and take 3 terms only in right side. Right side has infinitely many terms, so taking only 3 terms, we are getting approximately. So approximately e is equal to 2.67. That's all.